Okay, now we're gonna know how to name ionic compounds. So there are some rules. They're pretty simple. So first of all, the cation always located on the first plane, on the first place, and when the name cation, we just use the regular name for the element. For anion, which is written at the last position in the formula, we need to use second. For example, let me start here. So CaCl2. We have two symbols here. Ca means calcium and Cl means chlorine. So calcium is on first place, so that means that calcium is cation and chloride. Here is anion. Why it's chloride? Why it's not chlorine? I already mentioned it because its charge is negative, and when it's negative and when it's a monatomic ion, so we need to change its name, its ending for EID. So it will be calcium chloride. The next one, sodium nitrate. You can say sodium. So we need to use this symbol sodium. And sodium has charge one positive. And nitrate, there is a nitrate ion. In your solubility table in the class we did this. We named all anions there. So find nitrate, and you can see there is a charge one negative. So when charges are equal, so you don't need to use any subscript here. So iron fluoride 2. So two symbols here. The first position is iron and fluoride in the second position. For fluoride known as anion, its charge will be negative. So 2 fluoride gives us 2 negative, and all ionic compound is neutral. That means that for iron it will be 2 positive, its charge. So I will use this name, iron 2. Why I mentioned 2? Because for iron it's possible to have charge 2 positive and 3 positive. In this compound it's 2 positive. That's why I'm using this iron 2 fluoride. Okay, ammonium sulfide. You can see IDE, that means that we will have sulfur in a negative charge. Ammonium is NH4 and its charge positive, NH4. Sulfide comes from sulfur and it's negative, group number 6, so its charge 2 negative, and you can see we have 1 positive and 2 negative. That's why we need to put here 2. Okay, so let's go next, and I think I'm going to write it bigger. Okay, iron 3 oxide, and now you can see here iron 3 that was I mentioned before. So iron has possible 2 charges, 2 positive or and 3 positive. So when I use this name iron 3, that means that this charge is 3 positive. So iron 3 positive. Oxide means oxygen, negatively charged, 2 negative. And when we have these kind of numbers here, we just put them. 2 goes here and 3 goes here, cross. Okay, iron, iodine 3. And now you see we have cation iron. I'm not sure what charge it has for now, and I'm gonna know its charge. And for iodine is group number 7. That means that when it's anion, it has a negative charge. So 3 atoms, 3 ions here gives us 3 negative together for 1 iron atom here, or for 1 cation iron. So that means that iron has 3 positive charge here. So iron 3 iodide. Okay, lithium sulfate. Lithium, in the first position, I will put this symbol lithium. This is alkali metal or group number 1. So it's charge 1, all this the same, 1 positive. And sulfate, look at your periodic, look at, not in the periodic, in the solubility table. SO4, and its charge 2 negative. So, and we now can see that charges are not equal. For 2 negative, we have only 1 positive charge. That means that we need to add another lithium, and lithium 2 SO4. Okay, the next one, potassium oxide. Potassium means K, oxide means oxygen. For potassium, charge will be always plus 1 positive, and for oxide it's 2 negative. As you can see now, for 2 negative we have only 1 positive charge, so K2O, potassium oxide. The next one, so we have oxide anion here, so 2 negative here, and calcium. Calcium, 1 calcium for 1 oxide anion, so that means that their charges are the same, but opposite in charges, 2 positive and 2 negative. So it will be calcium oxide. Okay, the next one, strontium and CO3, CO3 anion with 2 negative charge. It's named carbonate, so it's strontium. Strontium has the same charge all the time, so 2 positive. Strontium, that's why we don't mention it here. So strontium carbonate. Okay, next one, copper 1 chloride. Copper, and copper is transitional metal, so it has variable charges. So for this case, it has 1 positive charge, and chloride is group number 7A. That means that when it's negative, it has 1 negative charge. So charges are equal, no subscripts here. So this is correct formula. Aluminum hydroxide. Aluminum, only 1 charge, 3 positive, and hydroxide, OH, is polyatomic ion, and its charge negative 1. So for 3 plus, we have only 1 negative. That means that we need it 3 times. You can see here OH 2 times in magnesium, so we will have the same type of compound, magnesium hydroxide. And the next one, aluminum nitride. Aluminum, 3 positive, always the same, and nitride means N, negative charge, 3 negative, because it's group number 5A. Charges are equal to each other, no subscript needed here. And this one, NO3, we know already it's nitrate. 1 negative is a charge for 1 polyatomic anion, and for magnesium it's 2 positive, so it will be magnesium. Oh, I'm sorry. Magnesium nitrate. Okay, silver phosphate, silver, Ag, its charge always plus, only one positive. Phosphate, PO4 and its charge 3 negative. So for one positive we have 3 negative. That means that we need to add 3 subscript here. Sodium hydroxide, so sodium charge 1, hydroxide or H polyatomic anion, it's charged 1 negative. Charges are equal to each other, no, nothing needed, nothing more needed. And Na2O, we can see here O the last position, that means it's oxide anion. It's charged to negative, and for sodium it's always 1. And it will be sodium oxide. Okay, just don't forget to use your solubility table where we made our notes. Okay, how can you identify an ionic compound just by looking at it? You need to identify it by finding metal and non-metal compound, or NH4 connected with bonded with non-metal. Okay, so a circular ionic compound, NaOH, it's sodium hydroxide, it's ionic because we have a metal and non-metals here. HNO3, it's not ionic because no metals here. P4 or 10, no metals here. H chlorine O3, no metals, no metals. Strontium is metal here. Okay, no metal, no metal. It's ionic because potassium is metal and chlorine is non-metal. It's ionic. It's ionic. It's ionic. No metal here. Only non-metals. No metal. Non-metals. No metal. Ionic compound. Ionic compound. Ionic compound. Why the name for iron and copper ionic compounds contain a Roman numeral? Because they have various charges. So for iron, it can be iron 2 or iron 3. Or for copper, it can be copper 1 or copper 2. Okay. Do you expect an ion to have a charge? Why? Yes, ion always have a charge because the number of protons not equal to number of electrons. Do you expect an ionic compound to have a charge? Why? No. Ionic compound don't have a charge, doesn't have a charge. Why? Because positive charge balanced with negative charge, so that's why it's neutral together. Why is the correct formula for aluminum bromide aluminum Br3 and not aluminum Br2 or aluminum Br? Because of charges, aluminum has charge 3 positive, bromine in group number 7 and its bromide anion has charge 1. We need equal amount of positive and negative charges. That's why we need 3 bromide here, and 3 bromide here gives us 1, 2, 3 negative charges, and 1 aluminum gives us 1, 2, 3 positive charges. What can you say about SO3 that does not have charge and SO4 that does? So SO3 is molecular. Molecules are neutral, and SO4 is polyatomic ion. So for 1 sulfur and 4 oxygen, there are 2 more additional electrons here. That's why it's negatively charged. So for SO3, the number of protons are equal for number of electrons for whole molecular, and for this compound, for this ion, I'm sorry, the number of protons is not equal to number of electrons, and by the way, the number of protons will be less than the number of electrons. That's why its polatomic ion is negatively charged. Where does the negative charge in SO4 to negative come from? It has two additional electrons. So, and by yourself, you need to finish practice problem set 2 and this chart number 2, 3, and 4, and yes. And don't forget to download this handout when you finish it to let me grade it. So I wish you good luck. I believe in you. You will be successful, and have a good time with your homework.